In the world of Elasticsearch, mapping management is the key to unlocking the full potential of your search applications. From dynamic field creation to intricate multi-field strategies, understanding and mastering mappings is essential for efficiency. Imagine sculpting the blueprint of your data structure, fine-tuning it for optimal performance. Now, let's dive into the core concepts, exploring the art of mapping management in Elasticsearch. Welcome to Chapter 1, Understanding Mappings, the Foundation. In Elasticsearch, mappings dictate how documents and fields are stored and indexed, acting as a blueprint for data interpretation. From text analysis to query performance, mappings are pivotal in enhancing search relevance and efficiency. Crafting precise mappings upfront can drive significant improvements in search outcomes and storage efficiency. In a world of data interpretation, mappings pave the way for enhanced performance and effective data retrieval strategies. Ever wondered how Elasticsearch handles new fields in your documents? Dynamic mappings have got you covered. Say goodbye to manual field definitions. Elasticsearch automatically creates them as needed. Strings transform into text fields, numbers find their numeric types, and dates are recognized effortlessly. No schema planning upfront means you can dive straight into indexing and adapt on the fly. Embrace the flexibility to evolve with changing data structures seamlessly, all while speeding up development with rapid prototyping. With dynamic mappings, your Elasticsearch journey just got a whole lot smoother. In the realm of dynamic mapping, we witness its power through a sample document, a glimpse into the Elasticsearch guide. With 350 pages, published on January 15, 2024, priced at $29.99, and currently available, this data structure comes alive through auto-generated mappings. The title is captured as text with a keyword subfield, page count as a long integer, published date, price as a float, and availability as a Boolean. However, a cautionary note rings true: while dynamic mappings offer ease, they can occasionally misinterpret types. Vigilance is key when reviewing auto-generated mappings in live environments. Take heed of the nuances within, for in the world of mappings, precision is paramount. In the world of data management, Chapter 2 introduces a powerful tool, explicit mappings. With these, you wield total authority over how your data is structured and stored. By meticulously defining field types, analyzers, and indexing preferences, you customize your system to fit precise needs and avert unexpected outcomes. This level of control is paramount for high-performance, accurate, and consistent production environments. Furthermore, explicit mappings unlock a realm of advanced functionalities such as tailored analyzers, multi-fields, and detailed field-level configurations that dynamic mappings simply can't match. It's like sculpting your data landscape to perfection, ensuring every piece fits flawlessly into the bigger picture. In the world of data mapping, explicit mappings play a crucial role. Why opt for explicit mappings? They offer a shield against type conflicts and mapping errors, boosting both storage efficiency and query speed. By customizing analyzers and tokenizers, you can fine-tune search results. Plus, with explicit mappings, you're in charge of which fields are searchable, ensuring uniform functionality across different setups. Consider this example of an explicit mapping for products. By specifying the type and properties of each field like name, SKU, price, and creation date, you define how the data is indexed and queried. In essence, explicit mappings provide a structured approach to data management, enhancing precision and performance. In the evolving world of Elasticsearch, the concept of mapping types has undergone a significant transformation. In the past, indices could house multiple mapping types, akin to tables in a relational database. Picture having distinct user and post types within a single index. However, this approach posed challenges, as fields with the same name in different types required identical mappings, leading to confusion and reduced flexibility. With the arrival of version 7.0, each index now accommodates only one mapping type. The subsequent removal of the type parameter in version 8.0 streamlines this further, emphasizing a single mapping per index. Elasticsearch's journey from supporting multiple types per index in 5.x to the abandonment of types in 8.x marks a pivotal shift towards simplicity and clarity in data organization. Field data types are the backbone of efficient querying, storage, and search precision in Elasticsearch. From text for linguistic analysis to exact value matching with keywords, each type serves a unique purpose. Numeric fields cater to mathematical operations, dates handle time-based searches, and Boolean simplifies flagging. For intricate document structures, there's object grouping and nested arrays for maintaining associations. With Elasticsearch's diverse field types, precision and performance are within your grasp. When selecting a numeric type, remember, smaller is better. Efficiency and performance are at stake. Consider the byte for small integers and flags, the short for ages and measurements, the integer for IDs and quantities, and the long for timestamps and unique IDs. Optimize resource usage by choosing wisely. Welcome to Chapter 5, where we delve into the world of object fields and their simple hierarchies. These fields are like organizational wizards, grouping related properties together in a document, forming a neat hierarchy. When indexed, they flatten out seamlessly, but beware of their limitations. Take a look at this document snippet featuring a user's details and an order date. See how they transform when indexed, losing some relational nuances in arrays of objects. Remember, while perfect for individual objects, the magic fades with arrays. So, tread carefully in the realm of hierarchies. A world of organized chaos awaits. Nested fields revolutionize data storage by preserving intricate relationships within arrays. Instead of losing vital connections, each array element is discretely stored as a hidden document, ensuring precise queries. Consider the dilemma of object arrays, a simple query mismatch due to flattened structure. Enter the nested solution. By storing each array element separately, relationships remain intact for accurate querying. Imagine querying Alice rated 2 and getting the correct result every time. With nested fields, this becomes a reality. So, embrace nested fields for data clarity and query accuracy. When structuring your data, the decision between using object fields or nested fields can greatly impact efficiency and functionality. For organizing related properties neatly and optimizing indexing speed, opt for object fields. This choice works best when dealing with single objects and when you prioritize storage efficiency. On the other hand, if your data involves arrays of objects with intricate relationships that require precise querying, nested fields are the way to go. However, be mindful of the performance trade-off and the increased complexity that comes with nested structures. Remember, while nested fields offer flexibility, they come with higher indexing overhead and require special queries. Use them judiciously and aim to avoid excessive nesting for smoother operations. In summary, consider your data structure carefully to strike the right balance between efficiency and complexity. Ever wished for a magic wand to streamline your index configurations? Enter index templates. These dynamic tools automatically imbue new indices with predefined mappings, settings, and aliases, saving you from repetitive setup tasks. Picture this, effortlessly ensuring consistency across a network of related indices. In the realm of time series data, where new indices sprout up like clockwork, or when managing a slew of akin indices, templates shine bright. So, Step 1, craft your template blueprint with mappings, settings, and index patterns. When a fresh index emerges, Elasticsearch plays detective, matching its name to template patterns. Voila! The matching template swoops in, tailoring the index to your predefined specs. Efficiency at its finest. Ever wondered how to create a powerful index template in Elasticsearch? Let's dive into the key components. The index_patterns specify which indices will use this template. Priority comes into play when resolving conflicts among multiple templates. Template mappings define field definitions, while settings configure the index. Additionally, aliases provide convenient index references. For example, by defining a template for logs ***, any new index starting with logs -- will automatically adopt these specified settings, mappings, and aliases. This streamlined approach ensures consistency and efficiency in managing indices. Are you tired of compromising between searchability and structure in your content indexing? Enter multi-field mappings, your ticket to the best of both worlds. By utilizing text fields for full-text search paired with keyword subfields for aggregations and exact matching, you can now analyze content for natural language queries while maintaining precise values for filtering and analytics. Say goodbye to duplicating storage significantly. Embrace the power of multi-field mappings for enhanced efficiency and flexibility in your indexing strategy. Implementing multi-field mappings allows for flexible search capabilities in Elasticsearch. By defining mappings for properties like title, we can optimize search queries for different scenarios. For full-text searches, we use the match query, ensuring relevant results like laptop are retrieved. For precise matches, the term query with .keyword identifies exact matches such as gaming laptop. Additionally, aggregations like top_titles provide insights by grouping terms. Through strategic mapping and query design, Elasticsearch empowers efficient and tailored search experiences. Dive into the world of common multi-field patterns. Text plus keyword, the quintessential duo for search efficiency. Multiple analyzers, unlocking multilingual search prowess. Standard plus edge engram, enhancing user experience with autocomplete and prefix matching. Remember, while multi-fields may increase storage, the benefits far outweigh the minimal impact. Keep tabs on storage usage and deactivate unnecessary subfields for optimal performance. Are you ready to optimize your mapping management practices for efficiency and performance? Plan ahead to avoid costly reindexing by designing mappings before adding data. Prevent surprises by disabling dynamic mapping in production, catching errors early. Optimize storage and query performance by using the smallest appropriate type for numeric values. Be selective with multi-fields to minimize storage and memory usage. Streamline consistency and reduce errors by leveraging index templates. And always document your decisions for clarity and future reference. Implementing these best practices will not only enhance your current operations but also set a strong foundation for future scalability and maintainability. Ever wondered about the common mapping pitfalls you should steer clear of in your data analysis journey? Let's dive in and explore key missteps to avoid. Using textual fields for exact matching may seem intuitive, but their tokenization renders them unfit for precise queries or sorting. Opt for keyword fields to ensure structured data efficiency. Beware of overnesting objects. Intricate hierarchies can complicate queries and stress mapping limits. Keep structures flat to streamline data access. Field cardinality matters. High cardinality keyword fields can strain memory resources during aggregations. Implement strategies like doc_values and sampling to manage vast unique values effectively. And remember, dynamic mappings, while handy in development, can lead to type inaccuracies and structural inconsistencies. Define explicit mappings for reliable production outcomes. In data mapping, precision is paramount to avoid pitfalls and optimize performance. In Elasticsearch, mastering mapping management is key to optimizing your data interpretation. Choose between dynamic convenience and explicit control based on your specific needs. Field type selection directly impacts performance and accuracy. Understanding text, keyword, numeric, and nested types is crucial for efficient search applications. Utilize multi-fields to index content in various ways, supporting different query patterns. Templates ensure consistency at scale by automating configurations across multiple related indices. While planning is essential, be ready to adapt as needed. Strike a balance between thorough preparation and practical iteration. Embrace the power of mappings to enhance your Elasticsearch experience. Takeaway: efficient mapping management in Elasticsearch is essential for optimizing performance and ensuring data accuracy.